Namaste everyone. Let us today learn about X-ray generation. X-rays are produced when energy conversion due to fast moving electrons are suddenly decelerated in the target anode. Produced by cathode, goes and hit the anode, deceleration and X-rays are produced. What happens in the anode is the way X-rays are generated. We will study today. Generation of X-rays in the anode can be by two processes. First is when the electron will interact with the nucleus of the tungsten atom, and second is when the electron will interact with the shell of the tungsten atom. Remember, nucleus and second is shell. If it interacts with the nucleus, this is known as Bremsstrahlung or general radiation, and if it interacts with the shell, then it is known as a characteristic radiation. General radiation, also known as Bremsstrahlung radiation. Bremsstrahlung means breaking radiation. Now what happens? The electron produced by the cathode goes and hit the anode. The anode is made of tungsten. This electron will pass near the nucleus of the tungsten atom. Tungsten nucleus of atom is positive charge and electron is negative charge. Therefore, the electron will be attracted towards the nucleus. Because of this attraction, there would be deflection of electron from its original path. There would be deceleration of the electron on which was moving, and because of this, it will lose energy, and the kinetic energy lost by the electron is emitted in the form of X-rays. Because there is a break in the moving of the electron, it got deflected. This is known as a breaking radiation or a Bremsstrahlung radiation. Now some points to remember. The electron which will be coming from the cathode going to hit the anode, these electrons will have different energy by which they will hit the anode, and also this electron will undergo many reactions before coming to rest. Therefore, there will be wide distribution in energy of radiation produced by Bremsstrahlung or general radiation, which we will see on the graph. Second point to note is that if suppose electron will collide head-on, means directly with the nucleus, all energy of electron will appear as a single X-ray photon. Now let us study about characteristic radiation. Bremsstrahlung was interaction with the nucleus. This characteristic radiation will be interaction with the shell of the tungsten target. Which shell? The inner shell or the K shell. What happens? The electrons coming from the cathode, it will go and interact with the anode, the tungsten end part. Here it will interact with the inner shell or the K shell of the tungsten target. Therefore, it will eject the K shell electron out. Therefore, both electron coming from cathode and K shell will leave. Therefore, the tungsten atom will be unstable. Now, because there is no electron coming from outer orbit, means L shell, will drop to the K shell, will lose energy, and this energy loss will be emitted in the form of single X-ray photon. Now let us see the diagram. First we'll draw the nucleus and the shell. Inner shell, 2 electrons. Outer shell, we'll draw the electrons. Now what will happen when electron from the cathode will come? Red color electron from cathode appear, strike the inner shell or the K shell electron. What will happen? Both electron from the K shell and the electron from cathode will be left outside the target, and now what will happen? This will become unstable. Therefore, tungsten atom is now unstable because the inner shell electron has been lost. Now what will happen? The outer shell electron will move down. It will lose energy. This energy loss will be converted into X-ray, a single photon X-ray known as a characteristic X-ray. Now let us draw the graph on one axis intensity and other the photon energy in kilo electron volt. Since I already told you that the Bremsstrahlung X-ray has variation, therefore it will be a curve, whereas a characteristic X-ray will only be single photon, therefore only one line alpha and beta. Now let us revise. First we'll draw the nucleus. The red colored electron from the cathode has appeared, passes near the nucleus, deflection occurs and the higher energy is converted into Bremsstrahlung. Second, the blue from the cathode, blue color electron from the cathode appear, ejects the inner shell, K shell, from outer shell, L shell, L electron falls to the K shell, it releases characteristic X-ray. Now, difference between Bremsstrahlung and characteristic is clear. Bremsstrahlung interaction is with the nucleus and characteristic is to the inner shell of the tungsten target.